when you guys have triangles that are congruent, let's say you've got two triangles that are congruent by side angle, or angle side angle. If you have two triangles that are congruent, in this example here, all you have are two angles and a side that are congruent. Well, what would you say about these two angles? They also have to be equal, because what happens is, once you have triangles that are congruent, all of their corresponding parts are also congruent. So if you can prove that two triangles are the same, that means all of their corresponding parts are the same. So if this was triangle A, B, C, and this one was X, Y, Z. For example, if we said that triangle ABC is congruent to triangle XYZ because of angle, side, angle, say we went through some proof and did that, I can therefore then say that angle B is congruent to angle Y, and the reason behind that is the following. It's very, very difficult. Take a deep breath. Corresponding parts of congruent triangles are congruent. So what happens here is that once you can show that triangles are congruent, everything else that corresponds within the triangles are also congruent. That's a good idea. So what happens is, this idea of the idea here of the cpctc, it stands for corresponding parts congruent triangles are congruent. So basically that means that after you get triangles congruent, all of the corresponding parts are congruent via that reason. Bless you. cpctc is only for the parts of triangles after the triangles are congruent. You cannot use it before it. You use it after.
So after you find either like angle side is that?
Yeah.
Right.
Well, not the angle side, because we know that there's no. Right. So nonchalant. Because, there's no ass in math. So. Yeah, and that's basically what this gets us to be able to do. So as we go through our proofs today, the ones from last night, I want you guys to see how this last step comes into play. It's that simple. It's one extra line. That's it. The difference here is that a lot of times in the proofs, they'll say, hey, prove angle A is congruent to angle B. It's not going to tell you how to get to the triangle. So you have to do just that little bit of more diligent work, but how you do that is by marking your diagrams. Marking your diagrams, looking for one of those 5 ways to show that triangles are congruent that we've been doing, that nothing of that changes, but this last final step is using this. Okay? So let's look at the problems we have from last night. I'll start with number 6, and I'll show you guys how this is going to work with this original proof statement that was there. So what I'd like you guys to do, hopefully you use pencil, erase all those crossouts that I had you do. Okay? And here's what I mean. Excuse me. Yesterday I had you just show the triangle ABC, bless you, the triangle ADC. Well, we're still going to do that, but we have to then show this last step. So I'm going to show you how that works. So here we have 2 given statements. So we have angle 1. It's congruent to angle 6. I've marked my diagram. 1, 6. Angle 3, congruent to angle 4. Also given. I mark my diagram again. So right now I have two angles. I need to find a side after the angles or a side between the angles. What do we have? Between. Very good. What do we call that side? Excellent. So AC is congruent to AC because of reflexive. Now you have two triangles that are congruent. Hopefully you wrote down these. I think we would triangle ABC congruent to triangle ADC. And the reason is angle, side angle. So now I have two triangles that are congruent. What do I know all about the corresponding parts? They're congruent. So all I can do is this then. AD congruent CB because C, C, T, C. That's it.
So a lot of course on this.
Yep.
So if it ends with, right, to find congruent parts, you know that you first have to show triangle congruency with one of those 5 reasons, and then you're gonna go to that. It's really important, you guys, that you mark the diagram. So start with the given, write it in your proof chart, write it, and make sure you mark the diagram. And then anything else you can prove. Look for that shared side, look for that X so you can see vertical angles. Those are gonna be important things for you to be able to point out.
This is the main reason why we harp on you guys about marking diagrams. So that way you can see which method of triangles you're going to get. Because it's not always going to be super obvious or super evident of how it sets itself up. By marking diagrams, it just opens everything. Okay? Did that help for that? Everybody see how quick that becomes though? Am I not crazy in thinking that this is starting to get a little bit easier? Well, I know that. Ah!
It's a little too early for that.
All right, I suppose. All right, same deal on 5. 5, you've got a little bit more work to do. 5, you've got a little bit more work to do. Oh wait, didn't we do this in our notes yesterday?
No.
It's a different version of it.
I don't know.
I thought we did.
Somewhat, yeah.
All right, let's go through it just for fun then, because it's always fun. S and U are right angles. What do you do when you are given right angles? What's that? But in triangles, when we're doing proof, so do we say equals? We're going to say, very good. So we say that they're congruent then. So, angle S, congruent, angle U. Reason. Very good. Diagram is already marked for us. Yay! T bisects segment SV. So when you have a segment bisector, what is created? 2 parts. Are those 2 parts equal? Congruent? What are they? They're congruent. You're ahead of me.
Wait, our bisector?
Yeah. Remember, you have 2 different things of bisectors. You can have an angle bisector or a segment bisector. An angle bisector creates 2 congruent angles. Segment bisector creates 2 congruent segments.
Same thing.
Very, very similar. It's just different word. Okay. So now you get those 2 parts that are equal. Write it down. ST. TU. Or is that a V? I think it's a U. All right. Definition. Segment. Bisector. Madison, you were saying something earlier?
I missed that step.
But you were saying something about some sort of angles that you found? I think you're right, vertical angles. Hey guys, I believe on our progression sheet, you guys have an example of vertical angles. And I think most of you guys have it where you just have the 2 lines being crossed. Do me a favor. It might not be a bad idea to draw it as a bow tie picture, because that's usually what you're going to see in triangles. Does that make sense? I would draw that as a bow tie picture because that's more prevalent It's gonna happen more often when we do proof stuff with triangles, because you'll see that within, you'll see that within the diagram, and it'll be quicker to recognize as opposed to just two lines intersecting. Is that helpful? I hope so. So now we have vertical angles, we just have to label them out. Angle STR, congruent, UTW, vertical angles. And by what method now do we have triangles congruent? What method do we have the triangles congruent? Excuse me. Did I say triangles or did I say angles?
I think you said triangle, but I said something.
That's okay. What do we have?
Angles.
Very good. We have our triangles now. Now, what if I wanted to say that angle R is congruent to angle W? What could I do? Why would those two be congruent? So what do we say? What's the letters? If we did the third angle here, we could have this and everything on the side if we wanted to. La-di-da. So the kite. Now I want you guys to pay attention closely on what happens here. If you erase what you guys had earlier about what they were asking you to prove, they were asking you to do, let me clear this out real quick. In this problem, they were asking, if you erase what you originally had on there, now this problem is asking us to show that AC is an angle bisector. What does an angle bisector do? Very clever. What is created when you have an angle bisector? Two equal angles. So in order for us to show that something has been bisected, we'd have to find something about, we have to see what two angles would be created if you bisected the bad angle. We'd have to get these two.
I forgot to laugh.
Yeah, so did I. We'd have to get those two congruent. Everybody okay with that? So in my mind, I need to be able to show that those two angles are congruent, but I have to get the triangles first. So yesterday, you did the triangle ABC, ADC, and hopefully that was really quick. So we have BC, congruent CD. Mark the diagram, thank you.
I notice sometimes this next step trips people up because you're not sure how to mark the angle. Remember that middle letter is the vertex. Start at B, go to C, end at A. Mark that angle. The vertex should be C, same thing.
I've
Start
noticed
at
that
D,
so
go
much
to
too.
C, go to A. Mark that angle.
I've seen that so much
Yeah.
lately too. I was very surprised by that. I don't know why people were freaked out about these two angles here. So you've got a side and an angle. What else can you show? The other, which side? The reflexive side. Excellent. So you write it. We have AC. Do you have triangles?
Yes.
Yes. By what? Good. So we have, don't you just ask me.
SAS.
ADC. Now, since we have to show that something was bisected, we have to work backwards from the definition. On your progression sheet, you have a definition of the angle bisector. You know that two angles would have to be congruent. So just work backwards from that. The two angles that would have to be congruent then would be angles BAC
So add this to your.
would be congruent to angle, what's the corresponding angle in the other way? If it's BAC, what would be the other one? If I said BAC, it would have to be DAC. Follow the letters. And those two are congruent because of the good old-fashioned cpctc. And now, since those two angles are congruent, I can therefore say that AC is an angle bisector because of the definition of an angle bisector. You're working backwards from the definition. That's all it is. To be honest with you guys, that's about as goofy as any of this stuff can get. That you're using a definition and a progression and all that kind of fun stuff, working backwards to show that a definition worked. That's quite literally as crazy as any of this stuff gets. Most of it is show this is congruent, show that is congruent, and so on. Okay? Was that terrible?
Yes.
You can do the same idea if you wanted to show something was a midpoint. You'd show the two segments were congruent, and you have a definition. Things like that.
Do you have to put that last step into a review?
Yes, you do, because it tells you to show this, so you have to say it. You're right, this shows that it happened, but this means you're done. Does that make sense? All right. Is that all right? No, that's C. They don't get any better throughout the school year, I'm sorry. Well, this one should have been really easy. Hey, what's the only thing you had to come up with on your own on this one? Reflexive side. So you wound up with what for triangles? Therefore, what do you say for angles B and C? Do I need to write it out?
No, John.
Okay. You have a reflexive side, gives you 3 sides, and you're done. Okay? Which leaves us number 2. And I think I've discussed with many of you guys throughout today's and flexes and things like that. When you're working with ones that deal with parallel, those always are the ones it takes a little bit longer to get accustomed to what they look like. Because following through where the transversals are is tough. So, in this case here, you know that you have 2 sets of parallel lines. So what we do is, we know this one's parallel to here. The trick is, take your parallel, hit the transversal, and come back down. So now, when I do that, those are the 2 angles that are created. Those are your alternate interior angles that are formed. Okay? You're following the transversal. So I know BA parallel CD. Then I have an angle BAC, DCA. When you're dealing with parallel lines and marking angles, what do you have to put in front before you talk about congruent? Yeah, that funky symbol. And these are alternate interior angles. Congruent. Okay. Do the same thing with the other one. Again, you're following through. As you look through your transversal here, you get these 2. So you have BC. Same reason. Parallel lines cut by a transversal. So now you've got 2 angles. You got to find a side after it. First side between it. What do you get? Reflexes. Very good. A lot of times when you see the both sets of parallel lines like that, hey, guess what you're always going to wind up with? Angle side angle. Because what it's creating is called a parallelogram. It's creating a parallelogram by doing that, and this does work. Lexi. What's up? I don't have your question. Do we have triangles that are congruent?
Yes.
By what? Two angles inside. So we have our triangles. And lastly, we can say that CD. And why are those two congruent? Nobody knows. Leave it blank. It's good. It's a good idea. That'll bode well for you. So it is quite literally one extra step. Okay? It is one extra step. So let's do some more. Yay!
Thank you. So much fun.
I ain't gonna see yet. You should have a little laughing about it. A little laughing about it, yes, this man was good.
I apologize for. I should have shrank these down a bit of less
He
paper.
made him pop it out of his style. No, he was doing it for 20. Hey,
I should have
he was doing
X
it
enlarged,
guys,
reduced. Yes. I
hey, leave Josh and Michael. Dying. Aru?
This is sweaty, guys. So.
You guys pass that.
So many files. Now, one of the things that we've done with these is that I know there's a lot on there, and I probably could have saved a small shrubbery or extra piece there. But I was trying to, I think about, I haven't really used much paper this year, so it's okay. The idea that I was throwing on here was that I was trying to get you guys as many different types of diagrams and scenarios that you basically can use. What's on here between this stuff and this few that I'll show you guys tomorrow when we talk about isosceles and equilateral triangles. Tomorrow I will give you guys out the review thing that we've made for the test coming Friday. So instead of actually doing problems out of the book on isosceles, equilateral stuff, it's actually already put into the review thing. Because you already know enough properties of them, I'm not going to make you guys do any proofs about isosceles or equilateral. They're kind of silly anyway. So a lot of those are going to be dealt with in algebra, drawing your own diagrams using the algebra out of it. Because it's pretty quick. Now with this then, what I'd like you guys to do, and we've got plenty of time to start walking around and helping you guys out here, is I want you to go through and do as many of these as you can throughout the class today. Oh, isosceles triangle. Hey, number 5, I just realized that. Don't do it.
Cross it off.
Yeah, don't do it. I'm not going to give you something that's found in isosceles triangle. That's just not.
I'll do it.
Okay? So, you have some time now have your progression sheet out in front of you and work through them, okay?